What we do here is go back.
Hello everyone, Yellow Mustang here once again with another Roblox scripting tutorial. Today, we are finally programming the tank. That is right. We're here and we're going to get this tank working. And I'm going to explain how everything works, how every line of code works. I'm going to break it down for you guys. And you guys are going to learn how to make your own tank today, hopefully. So, starting off here, let's look at some of the important things that we're going to be programming today. So we got the barrel here with the flash and a force field so it doesn't break when it gets hit with an explosion. Got like a shoot sound in there. We got a smoke attachment spot, so after it shoots some smoke, comes out of the barrel. We got engine and explosion sound effects for the engine part, which is like underneath the main gun there, directly underneath. And the gun back main is like an invisible part here that is used for the aiming. We just aim off of the C-frame for this thing and we rotate it and stuff using this weld. So we'll be adjusting the CO of this weld in order to make the gun of the tank actually aim at stuff. And then, let's see what else is important here. In the torso, which is like hidden inside here, everything's like welded to the torso. I got the body gyro. So we have the humanoid auto rotate turned off. So we're rotating the tank through body gyro instead. So we have a slow rotating effect. Because before I was using the humanoid auto rotate and it like kind of snaps. And it just looks super glitchy for, you know, a slow-moving tank. So I figured we would just switch the body gyro and call it a day. And so far it's worked out pretty well. So let's start off here. The first variable we want to get set up is for the respawning. Okay, so you got the clone set up there so we can easily respawn the tank if need be. Next, we're going to do a latency thing. So we're going to get all the descendants of the tank, and then we're going to check if it is a part. Then continue. So if it is a base part, which is going to be every one of these parts that you can actually see in the workspace. And then we're going to set the network ownership on the part. So if V can set network ownership, then continue. So if we have the ability to actually change the ownership on these parts, then we'll go ahead and continue, and then we will actually set the network owner to nil. So if we set the network owner to nil, that means the server is going to be processing the physics for the tank, which is what we want because all the code for the tank is server side. So since the code is server side, we want the physics to be server side as well. So there's no delay in between the code telling the parts where to move and stuff. So it will give our tank a much smoother appearance to players in game. So that'll look good. Next, we're going to go ahead and set up all the body variables. I'll go ahead and speed up through this part. Okay, so the next thing we're going to set up is all the gun part variables. Go ahead and speed up through this also. Okay, with all of those declared, we'll go ahead and move into the sound variables. Okay, now we're going to be setting up the variables for the settings of the tank. Okay, so next thing we're going to do is set up a table here that will hold all of our touched events. and this is for each part in the tank is going to detect if it hits something and deal damage to humanoids that it runs over, essentially. So we're going to store all of the touched events in this table once we generate it. Then we got to set up a path args table, well, dictionary table in this case. We're going to do agent radius equals 11, agent height equals 13, then agent can jump equals false. Okay. Then we'll set up some more tracking variables here for the guns. So local gun cool equals true. That'll be our gun cooldown. Local path blocked equals false. This will fire if we hit an obstacle or something. Then we'll do initial adjustments. So engine sound, we're going to just play right off the bat because the tank is going to be alive when it spawns. So we want the engine to be on, essentially. And then we're going to set the body gyro C-frame equals to mytorso.cframe. And that is just to update the body gyro so the tank doesn't spin randomly when it starts off. Because currently the body gyro is set to, like 000 C-frame, so it will rotate the tank like randomly. And we don't want that. And then barrel smoke dot parent equals nil. So this is to, for the smoke effect, when we shoot, we're essentially just going to be flipping the parent from nil to that attachment in the barrel. So has a nice fadeaway effect as we do that. Next, we're going to set up a spawn function. Okay, so function, spawner, func, ... So as everyone knows from my coroutine video, we should never use spawn, right? But spawn is so easy to use, it's hard not to. So in my scripts now, I simply set up this spawner function where you can feed it a function and then the arguments here. And that way it will run the function on a new thread instantly without using spawn. So I found that's a nice way of doing that. Works for what I need it to, at least. Next, we're going to go ahead and set up the engine pitch adjustment. And we're just going to go ahead and set up a spawner function because this is going to be running on its own loop. So we'll go ahead and put this in a repeat, weight 0.1. If my torso velocity is greater than 5, or my torso dot rotation velocity dot magnitude is greater than 5, or 0.1 in that case. And we need a magnitude on the velocity as well. So we're doing my torso dot velocity, and that velocity is a vector3 value. We use magnitude to basically convert this into a normal integer. So if it combines all the values and it is greater than 5, then we're moving at a speed in which the engine sound should be a higher pitch. So we'll do game, get service, tween service, create, and then we'll have the engine sound is what we're going to be tweening, and we'll just do a tweeninfo.new, 0.2 second tween transition from the lower pitch to the higher pitch. So that way it doesn't jump all of a sudden. It sounds much better if we have a tween in here. So we'll just go ahead and tween the play back speed, set to 0.35, and then we'll just go ahead and play that. And then we could throw a else in here, and we will just copy this line. So we'll do else, and this is if the tank is moving too slow, essentially. If the tank is moving too slow, then we will adjust the playback speed to be slower, which will give it a deeper pitch to the engine sound. So that will give us the... it'll sound like the engine is actually doing work, is essentially all this is doing for us. So now we'll do my human.health is less than 1. Then it stops. So for as long as the tank is alive, this loop will keep running. Well, actually, we don't need 0.1 in there. Just be wait. Yeah, so this loop is just going to keep running until we die, essentially, because we always want the pitch to be adjusting. This is a very fast running function, but it's pretty lightweight, so it's not that big of a deal for us. Next, well, actually, let's go ahead and run this in the workspace here and see if we can hear the tank. And you can hear that rumble in there. So let's go ahead and open up the tank and go into where the sound is, which is in the engine, which I scrolled past. Engine, okay, engine noise. And you can hear right now it's at 0.3 because the tank is standing still. I don't know. Will this detect velocity if I do this? No, it won't. Okay. Well, you guys will be able to hear the difference once we actually get the tank moving. But you can see right off the bat 0.3. So that seems to be working okay. Next, we're going to set the team color. So we'll do for IV in iPairs. Script.parent. Get descendants do. And this is just going to loop through everything in the tank. So we'll do if V is a base part. And v.name is not equal to headlight. And v.name is not equal to status. Then continue. So this is going to set the overall color of the tank. And we don't want the headlights to change color because no matter what team the tank is on, we always want them to be like this nice white look we have for them. And then the other part we're ignoring is the status because this needs to indicate what mode the tank is in. We'll code that in later, but there's no point in changing the color of this part. But everything else is basically free game to change the color on. So that's why we do that. So continuing on, so we'll do v.brick color equals body color dot value. And so we're going to set every brick color that we get to the body color value, which is this little guy over here. And right now we have it set to be ghost gray. So now if we run this, you can see it colors the tank to be whatever team we want it to be on. So instead of having to, go through and highlight all the parts, we can just change this one brick color value, and then we have a very customizable tank, which is great for setting up, NPC battles or whatever you want to do with it. Doesn't matter to me. Next function we're going to create is just a simple check dist. So it's just going to return the distance between two parts that we feed to it. So it's just going to return part1.position minus part2.position dot magnitude. And that's all there is to that. This just I find myself checking the distance between parts a lot, and I find that having this function saves a lot of space, especially when I'm checking on if statements. So I use checkdist a lot, so just created this simple function for that. The next thing we're gonna do here is the check site function. I'm gonna do function check site target. So we will be able to feed this function a target of like a torso or something, and see if we can draw a ray to it essentially. So we'll do local ray equals ray.new my torso.position as the starting point, and then we're going to tell it the direction. So target.position minus my torso.position.unit times site. And that site variable we declared up here, which is 200. So the raycast is going to be 200 studs out from our torso position towards the target. Okay, so all this is just drawing a straight line. So local hit position equals workspace, find part on array with ignore list, plug in our array, and then we plug in a table of what we want to ignore. And plugging in script.parent is going to go ahead and ignore all of the parts that are within our tank here, so that way it doesn't glitch out and for some reason hit like our armor. And then we're going to draw a second ray. So the first ray comes from our torso. The next one needs to come from our gun back main. And if you remember, gun back main is here. So we're drawing a ray cast from back here to ensure that we have a line of sight before we try and shoot something, so that way we don't shoot at a wall or something like that. So starting position will be the gun back main position, and then the direction. So same thing again, target dot position minus gun back main dot position dot unit times sight. Okay, and that will give us a clean raycast in the direction of our target, and that will let us know if we can see or not. So we'll just put a 2 after everything here. So hit 2, position 2 equals workspace, find part on array with ignore list, plug in our ray 2, and then plug in script.parent once again, so it ignores us, and that's all good. Now we'll do if hit and hit 2, then continue. So we're doing if hit, we'll just continue as long as hit is not equal to nil. And same thing with hit 2. As long as a part is assigned to these two values, then we will continue. And then we'll check if hit is descendant of target.parent, and hit 2 is descendant of target.parent, then continue. So this is basically detecting as long as the hit part is a member of the target model. So when it's drawing the ray, sometimes it won't hit the torso, sometimes it will hit the figure's arm or the figure's head. We're checking is descendant. So as long as it's a descendant of this figure model, essentially, then it will return true. So it doesn't matter if we don't hit the torso per se, it will return true even if we hit other body parts, and that way we won't get false negatives when we're checking the site. So that is a very good way and efficient way of doing that. So if we can draw a ray to one of the body parts from the torso and the aimer, then we will return true. As in true, we can see whatever our target is. If we don't return true, then we're going to return false by default, because obviously something went wrong with the raycast and something either got in the way or we didn't hit anything at all. So we will return false, like no, we cannot see the target. So that's pretty good there. So let's actually create the function to find the target. So function find target. Local dist equals detection. We declared that detection variable up above. I believe it's at 3000 right now. But I have this variable stored up at the top just for ease of access, so you don't have to scroll down and look for that. Local target is a placeholder for the tank. And then we're going to set up a table called potential targets equals blank. We're going to hold all of our potential targets in there, obviously. And then local C targets equals blank table. So any targets that we can do check side on and actually see, we'll put them in that table. So the first thing we want to do here is for blank in iPairs, workspace, get children. We'll do local human equals v, find first child humanoid. Local torso equals v, find first child humanoid root part, or v, find first child torso. So this is going to check whatever object we are on in the workspace. for a humanoid, and this is going to check whatever object we're on for a torso part. And by that, I just mean like a central part to aim at. So it could be a humanoid root part. If we don't find humanoid root part, then it's going to check for torso. So it can be either one of those is acceptable in this case. So if human exists and torso exists, and v is not equal to script.parent, so it's not our self that we're looking at in the workspace, then continue. And then we're going to do if my torso.position. No, actually we're not going to do that. We're going to use our checkDist function. So we're going to do checkDist my torso, and torso is less than dist. So this is going to make sure that we are within the distance that we have specified, which is 3000 in this case. And we're going to make sure that the human.health is greater than 0, and we will continue. So as long as whatever we are looking for is alive and they are close enough, then continue is all that means. Next, we're going to do the allies list. Did I create the allies list? I think I forgot. I think I definitely forgot. Yes, I did. Okay, great. Under barrel smoke. Okay, so right here. So we also want to create another table up at the top here called local allies equals script.parent.name. And then you can add as many allied names you want in here. So you can add marine or figure or civilian or whatever. This table is going to contain all of the names that we do not want the tank to attack. So this is our allies, these are our friends. That's our friend table, is how you can think of that. So let me get back on track here. A little bug in the system. Next, we're going to do for ix in I pairs, allies do. So we're going to loop through our allies table now for everyone. So the ally that we're currently on will be represented by X. The current number of allies that we're on is I, so starting at 1, 2, 3, etc. will just count up for every ally that we're checking. And we'll do if X is equal to v.name, then break. So this might be a little bit confusing, but bear with me here and try and understand. We're going to loop through all the allies, and we're going to check if v.name is in the allies list. So if we find v.name is in the allies list, which is X in this case, we're going to break. And we're breaking out of this loop because we're not going to assign target as something that is in our allies list, right? So it will loop through, and if it does find it, then we'll just go ahead and break because we don't want to attack our allies, right? So we'll do else if number allies, then continue. So if the current index I is equal to the number of allies, then continue. So the number of allies is 1 right now. So if I is equal to 1, then we will go ahead and do this. If if we find that it's not on the allies list and we're on the last ally, essentially, then we're going to go ahead and consider them a valid target to attack. So table.insert, potential targets, torso, and then there we go. So we will just go ahead and scan the whole workspace for targets within our range that are not on our allies list, and then we will put them in our table so we can further sort through them, essentially. So continuing on down here, now we'll do for, well no, not for, sorry. If number of potential targets is greater than 0, then continue. For IV in I pairs, potential targets, do. If check site. Oh, sorry. So let me explain this. So if we have found at least one potential target, then we're going to continue. If we found 0 potential targets, then there's no point of doing any of this. So we just won't. Well, actually, we don't need this. We do not need that at all. Yeah. Never mind. Changing the code. Okay, so we're just going to loop through the potential targets. If this is 0, this won't run anyways. So this will be more efficient. So we'll loop through all the potential targets, and then we'll do if check site v, then table.insert c targets v. Okay, so this is just going to run all the potential targets into our check site function, and then if we can raycast from our torso and gun back main directly to the target, then we can consider them like, you know, we can see them, right? So if this returns true, then we'll go ahead and just put them in the C targets table, and we will prioritize the targets that we can see. Okay, so that's how that's going to work. Let's see here. So now we'll do for IV and I pairs. C targets do. So if we have any C targets, then we'll go ahead and loop through them and just find the closest one. So we'll do dist equals site. I will do for IV and I pairs. C targets do. So wait, what? No. Ignore that. Glitch in the system. Yeah, so we don't even need to do that. We're just going to do for IV and I pairs, C targets do. We'll do if check dist my torso V is less than dist, then continue. Target equals V, and then dist equals check dist my torso V. Well, I guess we could be a little more efficient here. We can do local variable here, and we do local distance from enemy equals this. So we can just go ahead and store that there so we don't have to calculate that 2 times. Distance from enemy, then local distance equals distance from enemy. Cool. Okay, so this is going to loop through all of our C targets, and we're going to check if the distance from enemy is less than our current distance, and current distance is going to be updated every time we find a closer enemy. So every time we go through the loop, we're going to keep finding enemies that are closer and closer to us. If they are further than the last enemy, then they will just get ignored, and we'll just loop over them, essentially. Yeah, so that is fine. And then we'll just check if target, then return target. End. Yeah, that should be fine. Going a little off script here, kind of redesigning this code as I go because I realize it could be done so much better. So hopefully this stuff works. No promises. It should work though. I'm pretty sure it'll work. It's pretty simple. Okay, so we'll check through our C targets. If we get a target from that, then we'll just go ahead and return it and then not do anything else. It'll save us some resources. If we don't, then we'll just find the closest potential target. So we'll do for IV and I pairs. Potential targets do. And we'll do, let's see. Potential targets do. We'll check the distance. So do if check dist V, or my torso V is less than distance. Then continue and math.abs my torso the position dot y minus V dot position dot y is less than 2. So we are making sure that the difference between our y position and the target's y position is less than 2 because the tank cannot really climb up things, so it needs to be essentially on the same level as us for that to be a valid target. That's all that means. So we will go ahead and do target equals V, and then distance equals a check dist, my torso, V. Okay, so that should be good. And then we will just return target. Okay, great. So that should be good. We should get a target either way. We should probably go ahead and do a test here now. So we'll just do a wait 1, and then we'll do print find target. So it will just print out whatever target is returned. So let's go ahead and run this and make sure we have no errors or anything. Humanoid root part, maybe we can print the parent. So find target.parent. And as you can see, it's obviously got figure targets here. So that part of the code is good. But we're running pretty long here on the recording time. So I'll go ahead and end the episode here. We'll pick it up next time. But I would like to thank you guys for watching. Please like and subscribe, and I will see you next time.
Oh fuck, I can't believe you've done this. Oh fuck, I can't believe you've done this. Oh fuck, I can't believe you've done this.